Alright, so last time I showed you how to create a simple web server using the Node MCU. So this was the code right here. And actually, if you recall, we have a web page, and that web page sort of act as our welcome page for our server. So basically, when you upload this code on your Node MCU and you open your serial monitor on the IDE, then you will be presented an IP address. Then when you visit that IP address using your browser, then you will be seeing a simple web page. Okay, and the code or the HTML for that web page is actually on the sketch itself. So here it is. This is just a simple sketch or HTML. I mean, so you have your H1 header right here, simple Node MCU web server. You have a P tag for a paragraph. Then you have a link for your LED on page, a button saying on, some spacing, another link to LED off, then another button says saying off, and then you have your closing for your links, for your link and your paragraph. Okay, and what this code looks like in the browser is just simple header and some buttons. So let me just show it to you. So basically, this is just reviewing what you did last time. So let me just upload this sketch. Of course, it's important that you specify your own SID and password somewhere here. So I given my SID and password. So this example creates or makes this Node MCU a Wi-Fi station, and then if you are connected with the same Wi-Fi as this one, then you can access this page right here. Okay, so right, it's uploading now. And so we'll wait for this number to reach 100%. Okay, then with that, we open serial monitor. So there will be that saying that's connecting to the Wi-Fi. Then that's it. It says that's connected to my Wi-Fi, and it gives an IP address of 192.168.1.74. So if I will visit this IP address on my browser, let's say this one. So this is the page that I'm talking about. So basically what this does is you can control this LED right here using the buttons on this page. So I click on, of course it's already on, and I click off, it turns off, and it clicks on, that turns it on. Okay. Now, what if we want this page right here to look much better? Or I mean, how about if we apply some styling, some scripts, some images on this page to make it look better? Okay. The problem with that is that you cannot actually create a string that is too long for the Node MCU's memory to handle. You see here, our page string is the HTML code, but there would be a limit on the length of this string. Okay, and there's actually no specification as to that limit, but there is a limit. And if you reach that limit, then there would be errors not on the upload, but every time you run or you turn on the Node MCU, there would be exceptions, and those exceptions will be visible on your serial monitor. Okay. Basically, also, unless you link to an external server for the images, you can't upload images here because this only contains string. Okay. So also, you apply styling or scripts, that would make the string longer, obviously. All right. So basically, to create a much more complex web page, okay, we need to use a file system, and that file system is actually supported by the Node MCU. Specifically, that file system is called SPIFFS or SPIFFS. That is short for Serial Peripheral Interface uh, Flash File System. So basically, that's a file system using the ESP8266 RAM, a portion of that RAM, and you can upload files to that. Okay, that's actually a percentage of the total RAM, and it's called serial because you are basically uploading files through the USB port towards the flash memory of your ESP8266. So it's serial transfer of data from your computer to this Node MCU. This is what I will show you in this video. Okay, so first things first is that the SPIF support is not on by default on the IDE. Alright, so what you need to do is download the tool for the SPIFs. Okay, and I will show you that in the next part of this video. Alright, so the first thing you need to do to enable SPIFs for your Node MCU is download the tools to enable that. So you have a link right here. So this is the link. I'll just provide this link on the description. So this actually downloads a zip file on your computer. Okay, and after that, okay, so once it's downloaded, okay, so you just go to downloads. You extract this one. Yeah, okay, so let me just show you the contents of this folder. So you have this and another folder tool, then you have your jar file, it's a Java file. Okay, so this one, you extract this. Okay, you need to extract this to your sketchbook location. So by default, that would be on Documents, Arduino, and this is now your sketchbook location. Then look for a Tools folder, and if it's not there, just create the Tools folder. Okay, then you extract this folder right here inside the Tools folder. Alright, so basically, you should have the jar tool or the tool, or you should have the jar file inside this folder right here. Okay, so you have your sketchbook location, this one. This is your sketchbook location. This is your tools. You can create that folder, or if it's not existing, then this is the extracted folder from the one you download. Another way, if somehow you change your sketchbook location, is that you can actually see that on your IDE. You can go to File, Preferences, and then you have here your sketchbook location. So here it's on my Documents Arduino folder, so that's my sketchbook location. If somehow you change that location, and then this is where that ESP8266FS folder should be extracted. Okay, and so once you have that folder extracted, that jar file extracted, then if you restart your Arduino IDE, there will be an extra option in the Tools folder, I mean Tools menu. So here you have an extra tool which doesn't appear previously here. So you have ESP8266 sketch data upload. So basically, this is now your tool for uploading any file to your SPIFS or your flash file system on your Node MCU. Okay. Now, just some brief background before we upload some files. Basically, a website can have files and folders. So I'll just show you an example right here. This is my WAMP folder. So if you're familiar with WAMP, this is how we run websites with PHP. Okay, so without without WAMP, we cannot run actually PHP locally. But we can just show you, we can run definitely HTML only web page, but not PHP. So these are example websites that I have. So we have here some examples. We have PR. Of course, these are all PHP. Okay. The point is, um, a website actually looks like just like your computer, right? So you have your uh, folders. You have your folders for images, for any other uh, content that you have, and you just need to access those folders on the browser so that you can show what this code looks like. So let me show you something that I created on my sketchbook. Okay, this is my sketchbook. Alright. So this is actually files from the website I created for the Node MCU. So you see here I have an index HTML. I have a lead off and you have lead on. Okay. So basically, when you visit the home page of a website, the browser automatically looks for an index page. Okay, it can be an index that's .php or an index.html. So in this case, since we are strictly on HTML, so we have here an index.html. Then I have another pages led off, led on, and I have images. And I have here my style. Okay. In order for all these files to be uploaded to my Node MCU, I need to create a data folder, the same location as my sketch. Okay. So this sketch is already including the support for SPIFFS. All right. So in order for again for the files to be uploaded to my SPIFFS, I just need to create a data folder in the same location as my sketch. Now my sketch is my updated sketch will be this one. Okay. So this one already has SPIFFS support. One thing you will notice here is that I have included a new library. FS, this is short for this is actually the file server header. Okay, the same parts right here for my SSID, my password, and so on. But the difference is that I have here my SPIFFS begin here. So this parts starts the SPIFFS, and if there's any problem, then on serial monitor it prints SPIFFS mount failed. And if there's no problem, then it will print SPIFFS mount successful. Alright, so it locks one S here. And then here, instead of using the server on, okay, let me just compare this with my previous code. Okay, so this part are actually similar. So here, actually, you see the server on function, and this tells you how the Node MCU handles clients who visits the home page, this one, the let on page or the let off page, right? It uses this function. But if you're using the SPIFFS, you will now be looking at it like a client visiting your files, right? So instead of using server not on, you will be using server on not found. And then I have a function here, handle file read, and this needs a parameter server.ui, basically the URL that the client is visiting. Then it looks for that file or that folder on my SPIFFS, and then it will send to the client through server.send. Okay. Now, if it's not found, then it will just say 404, which is the HTTP error code for not found. Okay. And similarly, I begin the server. Okay. If you look at this old code and this new code, they're basically the same. The loop is also the same, but there will be additional functions on my new code. So this is the function, the handle file read function. So again, it accepts a string path, which is actually the URL of the files. So it will browse through all the files on my SPIFFS, and then if it exists, then it returns the contents of this file on the browser. So if it's an HTML, then you can view that HTML code. So what I did here is that, again, I'm showing you the files. I created three HTML files, right? So if the user visits the server homepage, then it will see the index.html. So this is basically what it looks like without, of course, styling. This is a preview. Okay. Then if the user clicks starts, it will or the user will be transferred to this page right here. Again, no images. Don't worry, I'll be showing you the output for this one. Then, depending on what the user will do, he will be redirected to either LED on or LED off. Alright, and you have your images and so on and so forth. Okay. So basically that's it. And let me show you, or let me upload this code to my Node MCU. And first, how do you transfer these files to my Node MCU? Again, you need to create a folder data at the same location as your sketch file. So this is my sketch file. Yeah, this is my sketch file, and this is my data folder. Then you have that. You go to Tools. Then it's ESP8266 Sketch Data Upload. So you click this. Okay, and make sure that your serial monitor is closed, by the way, before you upload, because again, this would be using your serial port, and if your serial monitor is already open, then it would result in a conflict, a data conflict. So you just need to close this one, then you click the sketch data upload. Okay, sorry. So I had failed to specify my correct board, the correct board. So you just select Node MCU. Okay, 1.0, right? Yeah. Then, by the way, for the size of your SPIFFS, you can actually select that here. So my board, the flash size of my board is 4 MB. So I can specify if I want a 2 MB SPIFFS or file system, 3 MB or a 1 MB. Okay, so you will be using 2 MB. That will be half of your total flash, and then you will still have around 1 MB for your over-the-air updates. This is actually an update done through Wi-Fi. Maybe I can make a separate tutorial for that. For this time, we'll be looking at file systems only. So you can choose between 2 MB, 3 MB, or 1 MB. Or you can just choose none. Of course, if you choose none, then you will not be able to upload on your script. So I'll be using this 2 MB right here. Okay. So make sure that your chosen file server size matches that of your data size. So if you go back to my data folder, check the size, that would be around 15.6 KB only. So that would be enough, or my 2 MB file server size is enough for this data to be uploaded. Okay, so once we have that specified, okay, then you just click ESP sketch data upload. Okay, so it says here uploading image. Alright, so let's wait for it to upload. Okay, it would take long depending on the size of the file you'll be sending on your SPIFFS. Okay, it says here SPIFFS image uploaded. So you can assume that our SPIFFS file have been uploaded. So let me just try that again. Okay, uploading image. So this is just second time, or just checking if it's really uploaded. Right. So if you can see the board, it's actually flashing, the LED is flashing. Okay, so I think that's about it. The image is uploaded. The next thing, of course, you need to do is you need to still upload this sketch right here. Right, so this is a separate location on your file server, on your, I mean, your flash. You just click upload. Okay, so we'll wait for this one to upload. So by the way, talking about the flash memory, you can actually visit my website. There's a simple graphic right there. It shows you how the flash memory is divided. Okay, so here you have your file system, which is the SPIFFS. This actually takes a big portion, and of course, this would be variable depending how you would allocate the file system, as I'll show you in the sketch on the ID. I mean, you have your sketch size here, you have your OTA updates, your Wi-Fi config, and your EFI. This is typically how the RAM is divided for the Arduino platform. Of course, it's different for other platforms. So I think, yeah, it's uploaded. My server is uploaded. I will open my serial monitor. Okay, just reset the board first. Reset. Right. Yep. Okay. Oops, what's happening? One more. Let me just reset again. Yeah, I think there's some error on my. Let's restart.
Goodbye.
Hello. Right, so that should do it. So, reset. Alright. Uh, yeah. Mm-hmm. Maybe I'm using the wrong. Right, let's check if we can. Let's upload, re-upload the sketch. So there's something wrong on the serial monitor. Actually, I'm assuming it would be using the same URL or the same IP address. Since I didn't change that. I will just re-upload the sketch. Alright. So maybe there's something wrong with the serial output. But let's try to visit the server now. Alright, so this is now our upgraded server. So you can see you have a different server. This includes some styling, and you have your button right here. So I click start, and I have my bob right here. This is actually rated for. So let me just show you the board. So this is the board. Okay, so this is my new server page. Okay, so if I click this one, so it turns on the onboard LED. If I click again, it turns it off. Right. So this is uh, better looking than my previous web server because I have incorporated some styling and of course some images. And all of this code is what's on that data folder I've shown you earlier. So if you're interested, I can show you the code. Okay, so this is the contents of my web page I created for my web server. So this is the index.html file. Alright, so this is what you see if you visit the homepage right here. So this one, the code for this one is here. So basically, you just have your basic HTML tags, your head, your body. So in my head, I just added the meta viewport so that it adjusts to screen size. Then a link to my style sheet, which is this one. So this is how I styled my buttons, my HTML body, and other things. Then my header, my header right here. Alright, so this is this header, this one. Then this link to the tutorial on my website. Then a paragraph. Then you have your button right here. If I click this button, this is actually links to lead off page. So this is my lead off page. Basically, it's the header, another a link, and then you have your image. So if you click this image, it will point you to lead on HTML. So this is now the lead on HTML. Basically, this is the same as lead of HTML, but the image is the same. Now, how did I control the onboard LED on my web page? If you go back to the sketch for this one, on my handle file read, okay? So here, you see that if the path is on LED on.html, then it turns on the LED, right? So it's low because our LED is wired as active low, meaning it turns on when you pass it a low value. And also, if you visit the LED off page, then it will turn off the LED. So that's why your onboard LED turns on and off depending on which page you are visiting. Okay, so this is how I control the LED. And basically, that's it. These are my 4 files plus the images. Then I uploaded that to my Flash file system, and then you have your output right here. Okay. So for more information about this setup, you can just visit my website. My written tutorial would be on the link below. So you can read all the setup, how to set up everything I've talked to about on this video. You can read it here, and hopefully that would clear things if you still have some confusion on how to set up the SPIFFS on our Node MCU.